Hi everyone, I am Necdet Uzduran. Today, me and my team at Arda Kabadayı will talk about our bachelor graduation project, Early Alzheimer's Detection with Multiple Modalities, which is submitted to the Department of Computer Engineering in partial fulfillment of the requirements for the degree of Bachelor of Science, Bogazici University, Spring 2024. Our project's main focus is investigating the application of word embeddings on multimodal training of real-world patient data. Throughout the project, we aim to improve classification performance of our neural network model between healthy, cognitively impaired, and patients with dementia using word embeddings and different multimodal learning techniques. As stated in the project description, we try to investigate effects of word embeddings on our neural network classifier. We try to come up with an implementation where we replace few of the categorical features where categories are represented with numbers such as 0, 0.5, and 1. The main idea behind our implementation is to capture semantic relationships between feature entries and achieve an improved performance for our classification task. In our first implementation, we simply combined word-embedded features with other raw numerical features and trained a single neural network directly. We used a pre-trained word embedding library called GLOW. Since it is pre-trained beforehand, this approach can be considered as a joint fusion multimodal learning approach.
After we apply joint fusion technique, as you can see, we cannot get any significant accuracy improvements. After we observe no improvements with joint fusion techniques, we want to see the distribution of data and whether it is linearly separable or not. For this, we use soft margin SVM and one versus all method. So as you can see, this is normal cognition versus all plot. The yellow ones are normal cognition people, and generally they are clustered similarly, so we can linearly separate them. Also, as you can see, this is dementia versus all plot, and we can linearly separate them also. So we concluded that our data, like similar labels, are clustered together and our data contains some sort of semantic information.
Later on, we came up with a different approach. We trained word-embedded features and raw numerical features separately on different neural networks, and combined the last layers of these networks using an aggregate function, such as a softmax function. The main idea behind this approach is to make neural networks to extract information from a single type of data and enhance overall classification performance.
As a conclusion, for our dataset, we use two different techniques. Each technique has their own advantages and disadvantages. For example, joint fusion techniques can capture the relationships in comprehensive data, while late fusion techniques can capture the distinct patterns in two different data. As we can see, we do not see any improvements in joint fusion, but there is approximately 2% improvements when we employ late fusion techniques.